Welcome to Shridevi Classes, official YouTube channel of Shridevi Women Polytechnic Hanumangarh, where we improve interest and confidence in science, engineering and design subject. Hello students, welcome to this learning video on applied mechanics, and our today's topic is practice of numerical problem based on parallelogram forces theorem. Now in this video you will learn how to apply parallelogram of forces theorem, and we'll discuss step by step solution of numerical problem, and we'll find magnitude and direction of resultant. In one previous video, we have learned parallelogram of forces theorem, and in succeeding learning video, we'll learn some real difficult problem on the same parallelogram of forces theorem. So let's start. To find out resultant of two vector P and Q having angle theta, we place tel of vector Q on head of vector P, and the resultant comes as tel of P connected to head of Q as a diagonal of this parallelogram. And when we simplify it, the magnitude of resultant is given as square root of first vector P square plus second vector magnitude Q square plus 2PQ cos theta, where theta is angle between the two vectors, and the resultant makes an angle alpha with one vector P, and the magnitude of alpha is given as tan alpha is equal to Q sin theta divided by P plus Q cos theta. In this first numerical problem, we have given two vector P of 40 Newton magnitude and Q of 30 Newton magnitude, and we have to find out resultant of these two when the angle between the two is 60 degree. We know as per parallelogram of forces theorem, the resultant magnitude is given as square root of P square plus Q square plus 2PQ cos theta, where P is magnitude of first vector, that is given 40 Newton, Q is magnitude of second vector, that is 30 Newton, and the angle between the two vector 40 Newton and 30 Newton is given as 60 degree. So theta is 60 degree. So we have just replaced the magnitude of P, Q and theta in this relation, and when we solve, P square, that is 40 square, comes as 1600, Q square 30 square is 900, and 2PQ cos theta is 2 into 40 into 30 cos 60. Cos 60 is 0.5, and when we solve it, it comes as 2400 into 0.5, and when we sum 1600, 900 and 1200, it comes as 3700, and when square rooted, magnitude comes as 60.83 Newton. To find out direction of this resultant, this second vector Q is resolved as two component, one along P, that is Q cos theta, and second perpendicular to P as Q sin theta. And when we apply trigonometry, then the resultant makes an angle alpha with vector P, and tan alpha is given as perpendicular Q sin theta divided by base P plus Q cos theta, and the value of P is 40, value of Q is 30, and angle theta between two vector is 60 degree. Sin 60 is 0.866, cos 60 is 0.5. When 30 multiplied by 0.866 and that is divided by P plus Q cos theta, P is 40, Q is 30 and cos 60 is 0.5, then this ratio comes as 0.4724. And to find out alpha from tan alpha, I have to take inverse function operation, and inverse of tan is tan inverse, and when tan inverse is operated on tan alpha, the result will alpha. So alpha is tan inverse tan alpha, and the value of tan alpha is 0.4724, and when from calculator we press first shift and then 10, the function operated is tan inverse, and when we place 0.4724, the result comes as in degree 25.28 degree. One significant observation is that resultant direction makes a smaller angle with higher magnitude. Here 40 Newton is higher than 30 Newton. So this angle is smaller as compared to angle with smaller vector, that is slightly less than 35 degree. So in total 60 degree, this resultant is tilted towards higher magnitude, as it is clear from the geometry of parallelogram. The diagonal bend towards higher magnitude. Two forces 50 Newton and 80 Newton acts at right angle. Find the direction and magnitude of resultant. So in case of two mutually perpendicular forces, the parallelogram simplifies and the resultant direction and magnitude is obtained simply by the Pythagorean relation that applies on a right angle triangle. Here in this magnitude relation, square root of P square plus Q square plus 2PQ cos theta, theta is 90 degree, cos 90 becomes 0. So this 2PQ cos theta becomes 0, and resultant magnitude simply become Pythagoras relation. Here base is P, perpendicular is Q, so the hypotenuse resultant is square root of base square plus perpendicular square. Now one vector is 50 Newton, second is 80 Newton, and when we square and add, 50 square is 2500, 80 square is 6400, addition is 8900, and when we take square root, it comes as a resultant magnitude 94.34 Newton. Now the direction of resultant with T Newton got a a relation. If this angle is alpha, then tan alpha is q sine theta upon p plus q cos theta. Theta is 90 degree. Sine 90 become 1, cos 90 becomes 0. So in numerator we have only q, and in denominator we have p, and tan alpha is perpendicular upon base. Perpendicular q is 80 Newton and base p is 50 Newton. Ratio is 1.6. Again, to find out alpha from tan alpha, I have to take tan inverse of tan alpha. So alpha is tan inverse of tan alpha. Tan alpha is 1.6, and when we take tan inverse of 1.6, it comes as 57.99 degree. Again, it is clear that resultant angular position shifts towards bigger magnitude. This angle with smaller magnitude is roughly 58 degree, whereas the angular position with higher magnitude is only around 32 degree. We have given two forces 20 Newton and 30 Newton, and the resultant is 40 Newton, and we have to find out angle between resultant with 20 Newton. This numerical problem definitely improve your calculation ability and enhance your analytical reasoning. The resultant magnitude is given as square root of p square plus q square plus 2pq cos theta, where p and q are two vector magnitude and theta is angle between, and angle which resultant makes with p is alpha, and tan alpha is q sine theta upon p plus q cos theta. Now here in these two relation we got 5 unknown. P, q are 3 magnitude, angle between two vector theta, and angle resultant makes with p alpha. So in fact we have 5 unknown, 2 relation. From 2 relation we can find out 2 unknown. So if we have given any 3 quantities out of these 5, p, q, r, theta and alpha, we can find out other 2. Here we have given p, q and r, and we have to find out alpha. But in this alpha relation we need value of theta, angle between two vectors. So for that we have to use this first relation, and we have to first find out angle between the two vector 20 Newton and 30 Newton. So we have used magnitude relation, and resultant r square is 40 square, first vector p is 20, so it is p square 20 square, q square, another vector is 30, is 30 square, and 2pq cos theta. Theta is unknown. Now when we square, 40 square is 1600, 20 square is 400, 30 square is 900, and this multiplication 1200 cos theta. To find out cos theta, we brought cos theta term to one side, 1200 cos theta, and brought remaining terms on another side. The sum of 400 and 900 is 1300, and when 1600 is subtracted from 1300 we got 300, and cos theta comes as 300 divided by 1200, 0.25. Now the positive value of cos theta simply indicate that theta is between 0 and 90 degree, and if cos theta comes as negative, if resultant magnitude is smaller, then the sum of p square plus q square may become higher than r square, and in that case you will get cos theta negative. That indicate that theta is more than 90 degree. But here cos theta is positive, so theta is less than 90. From cos theta we can find out theta simply by the cos inverse of cos theta. When inverse function operates one after another, the result is first parameter on which first function is operated. So cos inverse cos theta is theta. So theta is cos inverse of cos theta, and value of cos theta is 0.25. So when 0.25 is cos inverted, theta comes as 75.52 degree. So we have obtained angle between two vector p and q theta as 75.52 degree, and angle which resultant 40 Newton makes with p 20 Newton, p is 20 Newton, q is 30 Newton, and angle theta is 75.52. Sine 75.52 is 0.968. When it is multiplied by magnitude of q 30, it comes as 29. Similarly, q when multiplied with cos theta, theta is 75.52, cos theta become 0.25. When multiplied by 30 comes as 7.5, and when added with 20 it comes as 27.5. So tan alpha comes as 1.06. To find out alpha from tan alpha, we have to tan inverse tan alpha. Tan alpha is 1.06. So tan inverse 1.06 comes as angle of resultant with 20 Newton as 46.7 degree. In this numerical, two equal forces 25 Newton each acts on an angle 120 degree. We have to find out direction and magnitude of resultant of these two. As per parallelogram of forces theorem, resultant magnitude is given as square root of p square plus q square plus 2pq cos theta, where p and q are two vector and theta is angle between the two. Here both p and q is 25 and theta is 120. So resultant magnitude r square is p square 25 square q square 25 square 2p PQ, again 2 into 25 into 25, and theta 120 gives cos 120. When theta is more than 90, cos theta become negative, cos 120 is negative 0.5, and this product 25 square is 625, and 625 multiplied by 2 is 1250. When multiplied with zero point 0.5, it comes as 625 with negative sign, and when 2 625 subtracted by 1 625, it comes as 1 625, that is 25 square. So when square rooted, resultant magnitude comes as 25 Newton. One can remember this, that for equal magnitude and 120-degree angle between two vectors, resultant also got equal magnitude. For 25 Newton, resultant is also 25 Newton. To find out direction of resultant, the fact is, when two vectors have equal magnitude, their resultant lies along the angle which bisects two vector, that is along this midway line. So for 120-degree angle, the midway line makes an angle 60-degree each from both vectors. Now we can resolve both these vector 25 Newton along midway line and perpendicular to this reference midway line, and this angle half of 120 is 60. So this is 25 cos 60. Cos 60 is 0.5, comes as 12.5, and the perpendicular to midway line component is 25 sin 60. Sin 60 is 0.866. When multiplied with 25, it comes as 21.65. So both vector have component along midway line 12.5 Newton, and perpendicular to midway line is 21.65. So for two vector of equal magnitude having an angle theta, the resultant comes along bisector line, and we can resolve these two vector, one along bisector reference line and second perpendicular to it. So half of theta is theta by 2, and reference line mid bisector component is p cos theta by 2, and perpendicular component is p sin theta by 2. Now perpendicular component equal in magnitude are opposite to each other, so they cancel each other, and bisector component add together, and resultant will become 2 times of p cos theta by 2, as it is clear from this parallelogram also. So when two vector of equal magnitude A got an angle 60 degree, take bisector line as a reference, and a resultant of these two vector comes along bisector line that make 30 degree angle with each force. Now resolve these two forces, one along midway line and second perpendicular to it, and perpendicular component equal opposite cancel each other, and midway component line add together become twice of A cos 30. Cos 30 is root 3 by 2. So this resultant comes as root 3A. The same can be proved by Pythagoras theorem. Both P and Q got same magnitude A, so P square, Q square and 2PQ both become A square, 2A square, and cos 60 is half. This sum become 2A square plus A square, 3A square, and when we square root, resultant comes as root 3A. So for 120 degree, resultant was equal to A, and for 60 degree it is root 3A. Similarly, for two vector of equal magnitude and angle 90 degree between them, again a resultant comes along the midway line. So take this midway line as reference and resolve these two vector, one along midway line and second perpendicular to this reference line. Half of 90 is angle 45, and midway line reference line component is A cos 45, and 2 of this is 2A cos 45. Cos 45 is 1 by root 2, and when you simplify, the resultant comes as root 2 times of A. That can also be obtained by Pythagoras calculation in this triangle, and the same can be obtained by parallelogram of forces theorem. For 90 degree, cos 90 becomes 0, so 2 PQ cos theta becomes 0, and this simply become Pythagoras of A and A, that is root 2A, and resultant is for equal magnitude just midway. So you learn and practice numerical problem based on parallelogram force theorem. Some tricky and more difficult problem will be dealt in another learning video on the same topic, that is numerical problem based on parallelogram forces of theorem. If you find this video useful, do subscribe this channel and share this video, and to support our YouTube channel Sridevi Classes and Sridevi Women Polytechnic, you can also join our YouTube channel. Thank you very much.